As I previously mentioned, substitution reactions would not be possible without leaving groups. Why? Because remember that the electrophiles do not have an empty orbital. So what that means is in order to make a bond, I'm always going to have to break a bond. And I can't break a bond unless something's going to leave. Okay? So what that means is that it's going to be important in this chapter that we know exactly how to recognize when something's a good leaving group and when something's a bad leaving group. Okay? So let's go ahead and get started and learn more about leaving groups. Okay? So as I said, leaving groups are what break a bond to make it reactive. And in general, we can use the same rules that we learned from acids and bases to predict when something's going to make a good leaving group. We just use the rules that would make something a good conjugate base. Okay? Because what a conjugate base, all it is it's something that's stable after it gains electrons. Okay? And that's exactly what a leaving group is as well. After accepting an electron pair, is it going to be stable or not? Okay? So how do we determine if a leaving group is good or bad? We use the same exact factors that affect acidity that we used for the acid-base chapter. Okay? So remember that we had a few factors that affected how stable conjugates were after they left. The one that we're going to use most often is actually just the element effect. Okay? Because it turns out there aren't that many good leaving groups, and we can usually use the element effect to describe all of them. All right? So I know it's been a long time, but what were the trends that we used for the element effect? We used electronegativity. We said that as something goes to the right towards fluorine, it's going to be more electronegative, so it's going to like to have a negative charge more. It will be more stable. But also, we used the size trend. We said that as a conjugate gets bigger, the easier it is for it to accept more electrons because it doesn't care. I use the word, it's a very squishy atom. It's got tons of electrons everywhere. So if it gains 2 extra electrons, it's not really going to care. Okay? So ideally, the best leaving group would be the one that's furthest to the right and furthest down. So that would be around down here around iodine. Okay? Now you can't get much lower than iodine because then you start getting into like these weird transition metals that are radioactive and probably like give you cancer. Okay? But iodine is a good place to end in terms of the trends. Okay? So this doesn't explain all leaving groups because remember we have other types of factors affecting acidity as well. Remember that there was the inductive effect, there was the resonance effect, all that stuff still applies. But in general, the element effect does a really good job explaining the really common leaving groups. So what I want you guys to do is go through this exercise. I've given you pairs of molecules. All you have to do is compare the 2 different pairs and see which one would have the better leaving group, okay? And go ahead and just try to use the factors affecting acidity to figure that out, and then I'll explain each one to you. So go for it.